We come to the Infoline 11 channel. Stay informed with Infoline 11, your trusted source for news and insights. Hello and welcome to my vlog on how does time travel actually work? In this video, we will be exploring the various theories and ideas behind time travel and the possibility of it becoming a reality in the future. Here's the index of what we'll cover in this video. 1. Introduction: what is time travel and why is it so intriguing? 2. Understanding the basics of time: what is time and how does it work? 3. Theories of time travel, exploring the different scientific and fictional theories of time travel. 4. The grandfather paradox: can time travel create paradoxes? What is the grandfather paradox and how does it relate to time travel? 5. Wormholes and black holes: how could we use these cosmic phenomena to travel through time? 6. The possibility of time travel: is time travel really possible? What are the challenges and limitations? 7. Time travel in popular culture: a look at how time travel has been portrayed in movies, TV shows, and books. 8. Conclusion: summing up the key points and discussing the future of time travel. I hope you enjoy this video and find it informative. Let's get started. 1. Introduction: what is time travel and why is it so intriguing? Time travel refers to the hypothetical ability to move through time in a way that differs from the usual experience of the passage of time. This could involve traveling to the past or the future, or experiencing time in a nonlinear or subjective way. The idea of time travel has fascinated humans for centuries, as it raises questions about the nature of time and reality, and opens up possibilities for exploration, adventure, and even changing the course of history. It has captured the imagination of writers, filmmakers, and scientists alike, and has been the subject of countless works of fiction and speculation. The idea of time travel has also been a topic of serious scientific inquiry, with physicists exploring the theoretical basis for time travel and its potential implications for our understanding of the universe. While time travel remains purely hypothetical at present, its continued exploration offers exciting prospects for expanding our knowledge of the universe and the nature of time itself. 2. Understanding the basics of time: what is time and how does it work? Time is a fundamental concept that refers to the experience of the progression of events or changes in the universe. It is often described as a dimension that allows us to measure and compare the duration of events or the intervals between them. Time works through the continuous flow of events and changes, which can be measured using clocks or other time-keeping devices. The standard unit of time used in most contexts is the second, which is defined in terms of the oscillations of a certain type of atom. One of the key features of time is that it is relative, meaning that it can be experienced differently depending on the observer's frame of reference. This is described by Einstein's theory of relativity, which shows that time is not an absolute quantity but is affected by factors such as gravity and velocity. Another important aspect of time is its arrow of direction, meaning that it flows from the past to the future and cannot be reversed. This is known as the arrow of time and is related to the concept of entropy, which is a measure of the disorder or randomness in a system. Entropy tends to increase over time, leading to the perception of a forward-moving, irreversible flow of time. Overall, time is a complex and multifaceted concept that is central to our experience of the world, and its nature and properties continue to be a subject of study and debate in philosophy, physics, and other fields. 3. Theories of time travel, exploring the different scientific and fictional theories of time travel. There are various theories of time travel, both scientific and fictional, which explore the hypothetical possibility of traveling through time. Here are a few examples. Special and general relativity: Einstein's theory of special relativity, which deals with the relationship between space and time, predicts that time dilation can occur at high speeds, where time appears to slow down for a moving observer relative to a stationary one. This effect has been observed experimentally and is used in GPS systems. General relativity also suggests that time can be influenced by gravity, where time appears to slow down in strong gravitational fields. Wormholes, a theoretical concept in physics, Wormholes are shortcuts through space-time that could potentially allow for time travel. The idea is that by entering a wormhole, one could bypass the normal constraints of time and space and emerge at a different point in time and/or space. Multiverse theory. The multiverse theory suggests that our universe is one of many possible universes, each with its own set of physical laws and properties. Some versions of the theory propose that it may be possible to travel between these universes, potentially allowing for time travel to occur. Fictional theories. There are many fictional theories of time travel, including the popular concept of a time machine that can transport individuals through time, as portrayed in H.G. Wells' The Time Machine and in countless other works of science fiction. Other concepts include the idea of time loops, where events repeat themselves in a cyclical manner, and parallel universes, where alternate versions of events can play out. While many of these theories remain purely speculative, they offer fascinating insights into the nature of time and the possibilities that exist within the universe. They continue to inspire further research and exploration in physics, philosophy, and popular culture. 4. The grandfather paradox. Can time travel create paradoxes? What is the grandfather paradox and how does it relate to time travel? Time travel has long been associated with the potential for creating paradoxes, particularly the grandfather paradox. This paradox raises the question of what would happen if a time traveler were to go back in time and prevent their own grandfather from meeting their grandmother, thereby preventing their own birth. The grandfather paradox is a classic example of a causal loop, where an event is its own cause. In this case, the time traveler's actions in the past would create a paradox, as their own existence would be negated, and therefore their actions in the past would never have happened, leading to a paradoxical situation. The grandfather paradox highlights the potential problems that can arise when considering the consequences of time travel. Other paradoxes include the bootstrap paradox, where an object or information is its own origin, and the predestination paradox, where events are predetermined and cannot be changed. However, many argue that these paradoxes are simply a result of our limited understanding of time and causality, and that they may not necessarily apply to the realities of time travel, if it were possible. Some theories suggest that time travel may be possible in a way that avoids these paradoxes, such as the idea that time travel would create alternate timelines, rather than altering the original one. Overall, the grandfather paradox and other paradoxes associated with time travel continue to be a subject of debate and speculation, and may ultimately be resolved as our understanding of time and the nature of the universe continues to evolve. 5. Wormholes and black holes. How could we use these cosmic phenomena to travel through time? Wormholes and black holes are two cosmic phenomena that have been proposed as potential means of traveling through time, although their feasibility and practicality remain highly speculative. Wormholes are hypothetical tunnels through space-time that connect two distant points, potentially allowing for travel between them. If a wormhole could be created and stabilized, it might be possible to use it to travel through time, by entering one end of the wormhole at one point in time and exiting the other end at a different point in time. However, there are many theoretical and practical challenges to creating and stabilizing a wormhole, including the need for exotic forms of matter with negative energy density, and the potential for the wormhole to collapse or become unstable under various conditions. Black holes, on the other hand, are massive objects with such strong gravitational fields that they can bend and distort space-time itself. It has been suggested that by approaching the event horizon of a black hole, it might be possible to use the extreme gravitational forces to warp space-time and potentially travel through time. However, entering a black hole would also be highly dangerous, as the tidal forces near the event horizon would be immense, potentially tearing any matter apart. Additionally, it is not clear whether or how a traveler could emerge from a black hole or whether they would simply be trapped inside. Overall, while the concepts of wormholes and black holes provide intriguing possibilities for time travel, there are still many theoretical and practical obstacles to overcome, and it remains an area of active research and debate in the scientific community. 6. The possibility of time travel. Is time travel really possible? What are the challenges and limitations? The question of whether time travel is possible is a highly debated topic in physics and philosophy, with no clear consensus among experts. While many theoretical frameworks, such as special and general relativity, suggest that time travel may be possible under certain conditions, there are also numerous challenges and limitations that make it highly unlikely in practice. Some of the challenges and limitations of time travel include: technical feasibility. Currently, there are no known methods for creating or stabilizing a wormhole, which is one of the primary theoretical mechanisms for time travel. Other potential methods, such as traveling near the speed of light or using highly dense objects like black holes, also face significant technical challenges. Paradoxes. As discussed earlier, time travel can create a variety of paradoxes, such as the grandfather paradox, that challenge our understanding of causality and may be impossible to resolve. Conservation of energy. Time travel would require the transfer of matter or energy across time, which may violate the law of conservation of energy. Uncertainty principle. The uncertainty principle in quantum mechanics suggests that the precise position and momentum of a particle cannot be simultaneously known, which may make it impossible to accurately determine the state of matter or energy that is being transported through time. Philosophical and ethical implications. Time travel could have significant philosophical and ethical implications, such as the potential for altering history or creating alternative realities, which may be difficult to reconcile with our understanding of free will and morality. Overall, while time travel remains a popular topic in science fiction and theoretical physics, the challenges and limitations suggest that it is highly unlikely to be feasible in practice. However, ongoing research in areas such as quantum mechanics and the nature of space-time may lead to new insights and possibilities for exploring the mysteries of time. 7. Time travel in popular culture. A look at how time travel has been portrayed in movies, TV shows, and books. Time travel has been a popular theme in popular culture for many years, appearing in numerous movies, TV shows, and books. Here are some examples of how time travel has been portrayed in popular culture. Back to the Future movie trilogy. One of the most iconic time travel movies, Back to the Future follows the adventures of Marty McFly and Doc Brown as they travel back and forth through time in a DeLorean time machine. The series is known for its humor, memorable characters, and creative use of time travel paradoxes. Doctor Who TV series. A long-running British TV series, Doctor Who follows the adventures of a time-traveling alien known as the Doctor as he explores the universe and encounters a variety of historical figures and sci-fi scenarios. The series has been praised for its creativity, storytelling, and exploration of complex themes such as morality and identity. The Time Traveler's Wife book and movie. The Time Traveler's Wife is a romantic novel by Audrey Niffenegger that tells the story of a man with a genetic disorder that causes him to travel through time involuntarily, and the impact this has on his relationship with his wife. The novel explores themes of love, loss, and the nature of time itself. Bill and Ted's Excellent Adventure movie, a cult classic comedy. Bill and Ted's Excellent Adventure follows the adventures of two teenagers who travel through time in a phone booth to collect historical figures for a history presentation. The film is known for its humor, memorable characters, and creative use of historical figures. Outlander book and TV series. Outlander follows the story of a 20th-century nurse who is transported back in time to 18th-century Scotland, where she becomes embroiled in the political and romantic intrigues of the time. The series explores themes of love, loyalty, and the impact of historical events on individual lives. Overall, time travel has been a popular theme in popular culture, offering a creative and imaginative way to explore complex themes such as history, morality, and the nature of time itself. 8. Conclusion. Summing up the key points and discussing the future of time travel. In conclusion, time travel is a fascinating and complex topic that has captured the imagination of scientists, philosophers, and the public for many years. We have explored the basics of time, the different theories of time travel, the grandfather paradox, the potential use of wormholes and black holes for time travel, the challenges and limitations of time travel, and how time travel has been portrayed in popular culture. While time travel remains a theoretical possibility, it faces significant challenges and limitations that make it highly unlikely in practice. However, ongoing research in areas such as quantum mechanics and the nature of space-time may lead to new insights and possibilities for exploring the mysteries of time. In the future, time travel may continue to capture the imagination of the public and inspire new creative works in popular culture. At the same time, ongoing research in physics and philosophy may lead to new breakthroughs and discoveries that shed light on the true nature of time and the possibility of traveling through it. Only time will tell what the future holds for this intriguing topic. Thank you for watching, and I hope you found this video informative. If you have any questions or comments, please leave them below. Please share and subscribe Infoline 11 channel.